Okay, my pen is upside down, but let's see here. So this time we're going to solve systems by using elimination. So solve systems by elimination. And what I find interesting about this method is, and also I'm very old, it's possible I just don't remember this, but I do not remember learning this when I was in algebra in high school. It totally left my brain, but I really like it. So, a few years back when I started teaching algebra, I was like, I've never heard of this. I have to look into it. And so I watched a few YouTube videos and I was like, whoa, mind blown. Now I know this method. So let me show you what this looks like. And again, I'm teaching you 3 different methods, okay, so that you can choose what method works for you. But I do want you to practice the different methods so that you will know and be confident in your choice, okay? So we have 2 equations here. I don't really love this example, to be honest with you, but we're going to use it anyway. Okay, so 2 equations. If we were solving this on a graph, we could solve them both for y equals mx plus b, and we would get a slope and we would get a y-intercept, and we would graph them and we'd see where they meet, and the world would be a happy place because we would know the answer. We could also solve one of these for a letter. It's not quite so easy as it was in the last examples because, right, we would have to not only move the y to the other side, but we would also have to divide by -2. We could do that. We are perfectly capable mathematicians, and we could do that. However, when you look at systems of equations, if you ever notice when you line them up like this, that one of them has the same number in front of a letter, that's when you want to use this elimination method. Now, there may be other cases, and I'll show you some of those, but that's going to be the first thing I want you to notice is, hey, I just wrote these out and they both have a -9y. That's weird. I bet I can use elimination. So that's what I'm going to show you right now. I'm going to move this out of the way because we're going to do it on this side. But we're basically going to line these up like a subtraction problem. Okay, and that's going to feel really, really weird. Okay, just trust me on this. And you know what? I'm going to write this in red so that you can see the difference. Okay, so I'm going to write this in red because I'm setting this up as a subtraction problem. Okay, now -2x minus a -4. So you have your -2x minus a -4. Now, minusing a minus is really plus, right? So -2x plus 4x is 2x. Okay. We have -9 minus a -9y. So that's plus. So -9y plus 9y is 0. So we don't have anything there. I'm not going to write anything there. Okay, and I have -25 minus a -23, so that's plus. So -25 plus 23, okay, that's -2. Now I have a problem I'm going to solve. 2x equals -2. I'm going to divide by 2 on both sides. X equals -1. Now, just like I was doing before, I'm going to plug that x in. I can pick either equation that I want. So I'll just pick the top one for, I don't know, because I have to pick one. I'm going to write in green again because the green I know you guys can see just a little bit better. So -2 times -1, that's my x that I'm substituting, -9y equals -25. -2 times -1 is +2. -9y equals -25. Let's subtract 2 from both sides. So this is -27 equals -9y, and divide by -9. So y equals +3. So I have an xy point of -1, comma, +3. So This is one way that you can do things. Let's do another example of this. Yeah, let's do another example. Okay, so I'm going to erase this again. If you need to come back to it, definitely do that. Okay, this next example that I'm going to do, you don't have, see how here we had the -9s matching? We're not going to have quite the same thing, and I'm going to show you how you can do it if they don't match, but you still like this method. Okay, so 2x plus 5y equals 1. 3x minus 4y equals -10. Okay, now the reason we call this elimination is, remember how we had that -9 business last time, and then we ended up with 2x equals -2, and like the y just went away. We eliminated the y. And so our question here is there something that we could eliminate to make this easier for us? Okay, that's kind of what we're asking our question. And you know how when you have fractions, if you want to do like 1/2 plus 1/3, you have to do like times 3/3 times 2/2. Now you have 1/6 plus 1/6. No, we don't. We have 3/6 plus 2/6. Sorry. We're going to have kind of an idea like that, where we're going to find something that's common, even if we have to do some multiplication first. So let me show you what I mean by that. And we're going to use those same numbers. So we have 2x plus 5y equals 1. We have 3x minus 4y equals -10. And our goal is to be able to find something that is like a match that we can then do elimination on. So what I would propose here is that we multiply everything in this equation by 3, and we multiply everything in this equation by 2. And the reason I'm suggesting that is because this 2, when it gets multiplied, is going to be 6x. When this gets multiplied here, it's going to be 6x, and then we can subtract them and make them go away. All right, so let's do that. So 2x times 3 is 6x. 5y times 3 is 15y. 1 times 3 is 3. So we've multiplied every element by that 3. Okay, we're going to do the same thing here. 2 times 3x is 6x. 2 times -4y is -8y. 2 times -10 is -20. And we're going to subtract these two equations. Setting up our subtraction here. 6x minus 6x is 0. We're not going to write anything down. Plus 15 minus a -8. So we're going to plus 8. So 15y plus 8 is 23y. Does that sound right? I feel like I should double check before yeah, 23y. Okay, equals, we have +3, okay, minus a -20, so that's +20, so we have 23. Oh, well, this one's weird. It's fine. It equals 1. So dividing by 23, we get y equals 1. Now we have to do our next step, which is plugging that 1 into these equations. We can plug it into either one of these original equations, or we can apply it into any of these. It really does not matter. Pick one, go with it. I always just pick the first one because I'm really boring. 2x, does it surprise you that I'm boring? Plus 5 times 1 equals 1. Okay, so we have 2x plus 5 equals 1. Subtract 5 on both sides, we have -4 equals 2x. And divide by 2, now it's getting small. We have x equals -2. So our xy pair is -2, 1. Okay, so if we were to make the y equals on the graph, we put them in the graph, we do all that stuff, they would meet at -2, 1. All right, let me do one more example. I know this video's starting to get long. Make sure that if you didn't catch that and you need to rewind, that you do that. That is why we have these videos, because you cannot rewind me when I'm talking really fast in a lecture, but you can remind me when I'm on a video. So please do that. So one more example here. Let's get this one written up on the board. 18x plus 21y equals 14. And then my next row is 6x plus 7y equals 2. All right. So in this case, remember, we're trying to get it so that we have something that we can subtract. So in this case, whoops, I would strongly consider leaving this equation just exactly like it is. 18x plus 21y equals 14. And see, I'm looking at this 18x and I'm thinking to myself, well, how can I make this 6x match it? If I wanted to do that, I would multiply this equation by 3. So now I have 18x. 3 times 7 is 21y equals 3 times 2 is 6. Okay. And now I'm going to subtract. So I have 18x minus 18x, that's 0. 21y minus 21y, that's also 0. So I have 0 on this side of the equation. My nose is all itchy. 14 minus x, that is going to be, well, not 0. 14 minus 6 is 8. Oh no, sadness has filled my heart again. I'm so sad because that doesn't make any sense. This is false. But remember, that's nothing bad. It just means that there is no solution. Okay. If we were to graph this, these two lines would have the same slope. They would be parallel lines. They never cross. That means we can't find an XY point where they meet. So it's not a freak out solution, not a freak out situation. It just means that there's no solution to this system of equations. Good luck. Practice.